All right, this is a video for Unit 1, Day 1. We will be covering this in class on either Tuesday or Wednesday, depending on if you're A or B day. This part of the lesson is about interval notation and domain and range. It's just a review of some concepts that you learned last year, so hopefully it won't be too bad. So in the past, you should have graphed inequalities like this on a number line, and so this notation should look familiar to you. So I'm just going to remind you how to do that. So we have our number line over here, and it's not labeled, so it looks like this is saying that x is between -2 and +2. So let's just fill in some numbers here. And if I want to graph this, you might recall that when you have an inequality like this type, that's an open circle. It on the number line, it does not include -2. So we would have an open circle here. And on the other side, it says x is less than or equal to +2. So this one would be in a filled circle like this. And that means that x could take on the value of 2. And then we would just fill in that area in between. So this is saying that our number has to be, we call it x, it has to be somewhere between -2 and +2, and it cannot include that -2. Sorry, I have some new settings on this smartboard, and it's a little weird. It leaves little icons everywhere. All right, so this next one says that x is greater than or equal to 0, but less than 3.5. Please don't let a decimal or something like this throw you off. I'm going to start this at -1. So for what we're doing in class, that 3.5 on the right side, we can just kind of notate that that's 3.5. I guess that kind of makes it look like it's filled in, but I'll just put an open circle here and maybe just notate 3.5. And then at 0, we would have a filled in circle indicating that it could be 0, somewhere between 0 and 3.5. And if you wanted to, you could count your number line by 0.5s, but it's fine just like this. And then this last one says x is greater than 1. So if we wanted to graph that, we would put an open circle here at 1, and x can be any value greater than 1. So it looks something like this. And so x can't be equal to 1 in that case, just anything as long as it's a little bit bigger than 1. So this is something that's maybe kind of an older idea. You may not have visited it very much last year. Another way to represent inequalities is called interval notation, and this is probably where you spent more of your time last year in Math 2. Interval notation and inequality notation are trying to communicate the same thing. They're just trying to communicate an interval or a set of values, but it's just two different notations for writing the same thing. So this is saying x is between 2 and 6. In interval notation, it would look like this. Now you might remember, this might look familiar to you hopefully, when you're using interval notation, you use that parenthesis to mean that it's not included, or sometimes we'll say it's open on that side of the interval. And you'll use a bracket if the value is included, and sometimes we'll say that that's a closed. So this is saying that the 2 is included. X could be 2, and this parenthesis is saying that the 6 is not included, or in other words, x can't take on the value of 6, just anything up to 6. So here's a couple that we're going to practice. This first one, the inequality and the graph are both here. If we wanted to write that in interval notation, we would say from -2 to 2, and that +2 is included, so we would use a bracket. So this notation here, is saying that x has to be between 2 and 5. So on our number line, we've got to label that. The 2 is included, so we would do a filled in circle here, and the 5 is not included. And you can have any combination of open and closed circles just depending on your situation. So if we wanted to write that as an inequality, we would have the 2 and the 5 as the ends of our interval. X can be positive 2, so we include the equal sign there as part of that inequality, but it's strictly less than 5, or it doesn't include 5. All right, this last one, x is between -6 and -3. Let me label my number line. So we have the two ends of our interval, both of those are open. In other words, neither of those are included, and it's just all of that space in between, all of those numbers between those two values. To write that as an interval, we would say the lowest value is -6, all the way up to the highest value is -3. In this case, they both are parentheses. Neither of those end values is included. So hopefully this is kind of ringing a bell. So when you have something like this, x is greater than 3, we know that the graph of that looks like this. What about the interval notation? X is between what two things? So we would say that it starts at 3 and it goes off to infinity. Probably you remember this as well now that you see it. So when you're using interval notation, you can use infinity both positive and negative depending on what your interval is. You would say it's from a number up to infinity if it's x is greater than a number. If x is less than a number, you would say it's from -infinity up to that number, whatever it is. When you're writing intervals, you always write them from the lower to the higher number. So it's the same case when you're using a -infinity. That's absolutely the lowest you could get up to the higher number. Always low to high. All right, a couple to practice. We already did this one. This would be from 3 to infinity. And so this one is from -infinity up to -3, and the -3 is included. So the graph is there. So if we're writing the inequality, this is pointing less than -3. X has to be less than or equal to -3. This last one, x is less than 0. Label a couple values here. So this would have that boundary right here at 0. It's going to be an open circle because it does not include 0, and x is less than 0, so it's going to be all the values that are lower than 0. So if we write that in our inequality, in our interval notation, would be from -infinity up to 0. This sheet is in your notes. It's kind of just showing you all those different combinations for your reference. It shows you both open and closed intervals on both sides. So that's just for reference if it helps you to look at it and see all those different combinations together. Okay, so the whole reason that we learn how to use interval notation and inequality notation is so that we can communicate intervals to other people, and some of the intervals that we need to communicate the most are domain and range. So you've been working with domain and range in the past. You should be familiar with these ideas. So just remind you what those are. Domain is the x values for which a function is valid. Sometimes we say that a domain is the left to right. We read it from left to right usually. And the range then, of course, would be the y values for which a function is valid. And for the range, I always like to remember that it is bottoms up. Start at the bottom, go to the top of the function. So here is a particular function, a little zigzag line function. So we want to give the domain and range of this function in interval notation, and then we'll also write it in inequality notation just so that we can sort of see both of those. The domain of this function, now remember domain is left to right. So the domain, the farthest to the left, would be right here at -6, and we're writing this in interval notation. It definitely includes that -6 value. And it looks like the function goes all the way over to 5. And I think that one is also included. Range is bottoms up. Now, please note, when we go from the bottom to the top, the reason that we do that is because we are always going from a low value to a high value. In the x-axis, the low values are on the left and the high values are on the right, so we go left to right. On the y-axis, the low values are literally on the bottom and the high values are literally up high. So we go from the bottom to the top. So in this case, the bottom of the function, the lowest value, is a 1. And the highest value of the function is 6. Now sometimes when it's a jagged peak like that, we're not sure whether that 1 or that 6 should be included or not. Typically on a function like this, if it looks like it actually does get to that value, we make the assumption that it does. If we're studying a particular type of a function family, we know the properties of that function, and that will help you be able to tell whether that those end values are included or not. But I think on this one it probably does actually reach the value 1 and the value 6. All right, so if we had to write that domain and range in inequality notation instead, the domain would be, well, x has to be somewhere between -6 and 5. Both of those ends are included, so we use the inequalities that have the equal part. And the range, well, range is a y value, so be careful there. You don't want to put an x when you're talking about range. And it's between 1 and 6. Greater than 1, less than 6. All right, so there's a few practice for you to try. If I were you, I would try to do them and then maybe pause the video while you're doing those and then check your work. I'm going to go through them pretty quick. So for this first one, we are writing an interval notation here. So we would say that the domain is from -2 to 7. That's left to right. The range is, the lowest value is a -1 all the way up to +2. Okay, on this one, it doesn't have an arrow, but we're going to assume that that's an arrow there. So for this function, we would say the domain is, and domain is x values left to right. We would say -∞ to 2. That 2 is not included. And I'm using this 2. I'm going from left to right. For the range, it's a y value, so I'm going to go from the bottom to the top. So the lowest value is -∞ and up to 2. Now that time I was using this 2. So it's kind of interesting. The domain and the range are the same, but the domain is using x values and the range is using y values. Okay, for these ones, we're going to use inequality notation. So we want to use our inequality symbols, whichever ones we need. So this first function, domain, that's our x values, left to right. Uh, Well, the farthest left is, well, everything, because we've got this arrow going off to the left. The farthest to the right is everything. Does anybody remember how we say that? It's everything. And in math, the way we would say that is all real numbers. Or we use the symbol for all real numbers. Okay, that's the domain. The range of this function, the y values, bottoms up. Lowest value is -2, and the highest value is infinity. It looks like it's everything above -2, or in other words, y is greater than -2. Could be equal to -2. This looks like an absolute value graph, which means it has a vertex right there. Now, sometimes people think that inequality notation is easier, and sometimes people think interval notation is easier. Personally, I think interval notation is easier. I think this is a little trickier, but different people like different things. Most of the time in Math 3, we don't care which of the two notations you use. Sometimes it'll specify, but like on a test, it might specify, but most of the time you can kind of write it however you prefer, because they're just two different ways of writing, communicating the same information. Okay, this last graph here might have something that you aren't sure how to deal with. It has this gap in the middle. So I wanted to remind you that if that gap, if it has an open circle that's directly above or below a closed circle, that's okay. It's a little jump or a little step, and as far as the function is concerned, uh, its domain isn't going to be affected by that. Sometimes it can affect the domain, but in this case it didn't. Like it might affect the domain if it went like this and then jumped to here. But because they're directly stacked one above the other, in our case, it's not going to affect the domain. Sometimes that can also affect the range, but again, in this case, it doesn't affect the range. So the domain of this function, the x's left to right, the lowest value is -2 and the highest value is 4. And we're trying to write it as an inequality. So x has to be between -2 and 4. Now it can include that -2, but it won't include the +4. So our inequality looks like this. And then for the range, we're using y values. It's from the bottom to the top. The lowest value is here and the highest value is here. So the y has to be between 1 and 3. In this case, we're going to say that it's hitting that value of 1 and 3 on those peaks. It's pretty safe to assume that, but as we talk more about this type of function later in the year, it'll be more clear. So there's the domain and range of that function. Okay, so that's it for reviewing inequality and interval notation. There's just the front side of the homework assignment will have you practice this a little bit, and then in class on either Tuesday or Wednesday, we also are doing lesson 1.2. I'm going to upload that as a separate video, so if you miss class on Tuesday or Wednesday, you'll need to watch both of those videos. Let your math teacher know if you need any other help or assistance with any of this part of the assignment.